Okay. Hello, this is actually a combination of 7-7 and 7-8 exponential and logarithmic functions. We're going to look at transformations, which is technically 7-7 of exponential and logarithmic functions, and we're going to see how we can identify an exponential function from the table on, that's really the only thing I want to do from 7-8. There's actually more to that, but we don't really have time for it. So let's look at this. You would need this little formula. So this is something good for your note card or for your formula sheet on the test. Keep in mind this right here is a 2, not a z. It's a 2. It could be any number, but we're going to go with 2 for the most part. Again, the A is your vertical stretch or compression. The B is your horizontal stretch or compression. The H, which you notice is in the exponent, is your left or right, and again keep in mind the plus moves us to the left, the minus moves us to the right, and then outside the plus or minus k moves it up or down. Also, we're going to find the asymptote here. Remember, the asymptote is that barrier that it can't cross. For the parent function f of x is equal to 2 to the x power, it's y equals 0. It will move when I move the function up or down, so keep that in mind. And this is a horizontal asymptote, and it will always be y equals for an exponential function. Okay, so what I want to do here is I want you to describe the transformations and where is the asymptote, and we're going to do several examples of that. The first example here is f of x is equal to 2 to the x power minus 4. Okay, so again, this right here is part of the parent function of this. Okay, so we don't need to worry about that. So then if you notice, that's like saying this was, say, outside in parentheses, like that, and the minus 4 is outside of that. So what does that do? It moves us down 4. Since I'm moving down 4, that means I'm also moving the asymptote down 4. So the asymptote is located at y equals negative 4, because to go from 0 down 4, you'll end up at negative 4. So keep that in mind. Anytime you move up or down, so your asymptote should be at y equals k. Keep that in mind. The next one, f of x is equal to 2 to the x minus 2. Okay, now notice there, that one's in the exponent, so that's your h. And we always think opposite, so that means I'm moving 2 units to the right. Now, since I am not moving up or down any, my asymptote stayed put, and is stayed at y equals 0. Next example, we have 2 to the times 3 to the x power plus 3. Don't worry about this 3 right here. Okay, just worry about the 2 that's outside and this plus 3. Okay, that 2 tells me I have a vertical stretch because it's bigger. It's a number bigger than 1 or bigger than the standard. The plus 3 tells me I'm going up 3, and since I'm going up 3, I'm changing my asymptote to y equals 3. With this one, I have got negative 1/5, parentheses 2 to the x plus 1 power minus 2. So I try to throw in a little bit of everything on this one. The negative means I have a reflection. The 1/5 means I have a vertical compression. The plus 1 in the exponent means I've got a, I go to the left 1. And then the minus 2 means I go down 2. Okay, now keep in mind, if I'm going down 2, my asymptote is at y equals negative 2. So my asymptote is right there. So most of these, again, I'm trying to reinforce. You've seen this with all these other different functions. It's just a continuous reinforcement of that. Okay, the next one deals with logarithmic functions. And it's basically the same thing, but the big difference is the logs. You have to be careful. The h will be in parentheses with the x. The k will be outside. So if you do not see parentheses, you got to be careful there. Also keep in mind that this time the asymptote is going to be x equals. And we might see a pattern. I believe, and I want to say it's going to be x equals negative h, or the opposite of h. But let's see. Okay, so for my first example here, I'm going to have f of x is equal to, and we're going to do the same thing. Describe the transformations and find the asymptote. Okay, x equals 3. Now notice here, this is not in parentheses, so that means that's a k. And that means you're going up 3. And since you're going up 3, you're not changing the asymptote because the log function's asymptote moves sideways. It's a vertical line that can move sideways. So this one is actually up 3. It has an asymptote at x equals 0. So we started at x equals 0. Okay, here's I believe another example. Notice now this time I'm putting inside parentheses. Okay, now that means I'm moving to the left 3. That will change the asymptote to x equals -3. Okay, so keep in mind it would appear that my asymptote should always be at x equals -h. That might be something to remember. Or the opposite of h, I should say. Okay, so here's a little bit longer of a problem. F of x is equal to 2 log parentheses x minus 1 plus 4. Okay, the 2 means a vertical stretch. So keep that in mind, remember. The minus 1 is going to be to the right 1. The plus 4 would mean up 4. Okay, and since I'm going to the right 1, that should give me an asymptote at x equals +1. That's it. So again, most of these should be fairly simple, stuff you've seen before, shouldn't be that bad. Alright, so now we want to determine if a function is exponential. Okay, to do that you need to see if the y's in the table have a common ratio. In other words, if you divide one by the other. When we're looking at linear, we want to subtract. When we look at quadratic, we want to do double subtractions. With exponential, we want to see if they have the same division. So, for example, here I have a table. I want to know if this is exponential, then I need to say what's 1 divided by 1/2, 2 divided by 1, 4 divided by 2, 8 divided by 4. If they all come up to the same answer, then this is an exponential function. Well, 1 divided by 1/2 is 2, 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. They all equal 2, so yes, this is an exponential function. Not a very hard problem at all. So let's do a couple more examples, and then we'll be done. So if I do this, I'm looking at this and I'm going, okay, is -1 divided by -3 the same as 1 divided by -1? Okay, -1 divided by -3 is +1/3. 1 divided by -1 is -1. Those two aren't the same, so then automatically this one is not going to be exponential. You don't have to do the rest of them like 3 divided by 1 and 5 divided by 3. The next one, 0 divided by 4, or 0 and 4, 1 and 6, 2 and 9, 3 and 13.5. Okay, so I'm looking at, is 6 divided by 4 the same thing as 9 divided by 6 and the same thing as 13 divided by 9. Okay, when you type those in the calculator, the first two will probably give you some answer like 3/2, while the second one gives you some type of decimal. You could always change the decimal, those fraction answers to decimals, and you should get that they all come out to 3/2 or 1.5. So the answer is yes, it is exponential because when you divided the y's, they came out to all the same answers. That is it for this lesson, and so hopefully you have a good understanding of it, and you'll be ready for the test when we get ready for it. Thank you very much.